You're watching the Intel Network and Edge V-Summit series with our focus today on 5G. 5G rollouts are well and truly underway with deployments happening worldwide. Intel has been at the forefront of this journey to 5G, working closely with its customers and partners on the foundational underlying network. We are beginning to see early deployments of the new 5G core and RAN, yet there is more work to be done to fully realise the potential of 5G. Joining me now to explain how Intel is helping accelerate 5G deployments and services are Cristina Rodriguez, who is Vice President, Data Center Group and General Manager, Wireless Access Network Division at Intel, and Alex Quach, who is Vice President, Network Platforms Group and General Manager, Wireline and Core Network Division at Intel. Alex and Cristina, welcome both of you.
Hey, Guy.
Hi, guys. Good to be here.
Alex, there is so much attention on 5G at the moment. It's receiving a lot of news coverage, but what is the current status of the industry and what progress has been made so far on 5G?
Wow, what a question, Guy. You know, at this point, I'd say we are well embarked on the 5G journey. Cristina and I are based in the US, and we're seeing, and we have seen early 5G network deployed in the United States. And we're seeing other countries, such as South Korea, such as China, Japan, countries in Europe, leading with 5G deployments over the past 2 years as well, with network infrastructure, new network infrastructure from new 5G base stations to handsets, mobile phones coming in to take advantage of the new spectrum that's been released. So all that is going pretty well. As we enter into 2020, in addition to a new radio access network, there is also the beginnings of a transition to a new 5G core network, which is necessary to deliver to the promise of 5G. And as I mentioned, we're really on a journey, and we're still at the beginning of this journey. 5G, under the auspices of the governing body, the 3GPP, really started off with the completion of Release 15 back in 2018. And that allowed for the early network deployments that we've seen so far. Release 16, which adds a number of features across the network, and from an end-to-end perspective, was just completed last month. And now the industry is rallying to deliver against the improvements and things that were actually introduced as part of Release 16. And then Release 17 is yet around the corner, and everybody's working on that now. So overall, I'd say there's, accompanied with the excitement, the deployments are actually rolling out really well, tracking per plan in certain countries, tracking ahead of plan, and it's a very exciting time.
And Cristina, why is the network so important if we are to deliver on the promise of 5G?
So yes, very, very good question. Let me start saying that we have been on a decade-long journey transforming since 4G, transforming the network, and that has laid the groundwork for 5G. The network is the backbone or central system at the foundation of 5G. Think about it, just like our bodies, right? The central, the circulation system or the nervous system with all the veins and arteries, providing the pathway to get to every part of the body, whatever is needed for it to survive. In some way, similarly, the network is providing the pathways to get the data and information to all the end points. In this case, we're talking about home, business, enterprise, vehicles, connected things, mobile devices. Since the first generation of wireless network to the fourth generation of wireless network, those networks couldn't have been designed with the foresight of the demands of 5G, the performance, the throughput, the latency, the reliability, the intelligence that is needed for the new 5G use case. That's why we said we needed an overhaul, we needed a transformation of the network. And this transformation that we're talking about give the network more flexibility, more agility, more scalability, able to adapt to conditions changing, to traffic patterns, different traffic patterns, to multiple and diverse workloads, again, associated to those new use cases coming with 5G. And that's what you will hear us talking about, cloud native designs and service architecture networks that will provide that programmability and that scalability that we need.
Thank you, Cristina. And Alex, how is Intel helping with this transformation to 5G, and how would you rate progress so far?
Well, as Cristina mentioned, we, Intel, actually have been contributing to the network transformation for about a decade now, with the advent of NFV back in 2011, 2012. We worked on closing out on the specifications. And then the entire NFV movement was really centered around, how do we get service agility? How do we drive innovation from a time to market perspective? And how do we, to get that innovation, how do we decouple previously integrated hardware, software solutions delivered in black boxes into the network? How do we decouple the hardware and the software so that we have innovation that can take place at different cadences and have everything come back together to have these time-to-market innovation solutions for service providers? And so, through the last decade or so, NFV has really come of age. And if you look at where we are in 2020, as part of the journey to 5G, which actually doesn't just stop at network function virtualization, but actually takes advantage and extends that into a cloud-native architecture and adopts the principles of cloud-native designs to really have full network automation, scalability, etc. All of that is actually in play today. The crossover between network function virtualization and fixed function is actually happened between 2019 and today. And if you look at the adoption of NFV worldwide, there's over 155 here plus NFV deployments in the core network, 58 deployments for the IP multimedia subsystems, which is a part of the wireless core, as well as the GI LAN across the entire globe, from North America to Latin America to Europe, to Asia Pacific, to Australia. All of that's in play and really gone into the majority of the adoption. Intel really provides key building blocks into the overall network function virtualization. As I mentioned, as hardware and software are decoupled, Intel delivers the majority of the high-performance hardware that powers the underlying 5G infrastructure. And we do that with a number of different portfolio solutions, from add-in processors to custom processors in the radio access network and base stations, to our flagship Intel Xeon scalable processor for the core network, running a lot of the 5G core functions, whether it's virtual or moving to cloud native. And then we have a number of different accelerators for artificial intelligence and machine learning. We have EA6, we have FPGAs across a number of different workloads within the network itself. And then a number of connectivity solutions, from network interface cards to optical modules to memory with the Intel Optane memory solutions, to also very key software toolkits where we can abstract the complexity of artificial intelligence solutions or network complexities, so that we make it easier for application developers to actually land their applications on top of these networks. And then lastly, a very critical point is as we decouple hardware from software and we move into a multi-vendor environment, certainly in this cloud-native environment, it is absolutely imperative that the ecosystem comes together and works on pre-configured, pre-tested, and pre-validated solutions to make it so much easier to get solutions deployed, tested in the network for broad scale. And so Intel has to work with a broad ecosystem of solution providers, from OSVs to ISVs to telecom equipment providers to communication service providers, to make sure that all these solutions that are now coming from a wide ecosystem can be deployed with peace of mind at scale in a time-to-market fashion.
Thank you, Alex. Cristina, let's dive deeper into this network transformation. Why is the RAN transformation so critical, and how is this work progressing?
So the 5G network is going to require a much more diverse set of solution deployments, right? We're going to need distributed, centralized, cloud, fully integrated solutions. We're going to need macro, micro, small cells. We're going to need a broad range of radio deployments, multiple frequency bands, massive MIMO. With all that, one solution does not fit all. We're going to need more than multiple type of deployments. So the operators are looking at it and say, okay, two things, right? One, the investment that they have done so far in the network, they need to leverage that. So the network that exists today need to be able to address the increased traffic coming from both 4G and 5G. And you will continue to see operators deploying the traditional way with a purpose-built hardware. At the same time, and this is number two, at the same time, there is a need, there is a thirst to bring innovations that we see today in the cloud and in the core, like Alex mentioned, where some of those network functions are running now in software. And with that, we provide additional flexibility and agility, as I mentioned before, a possibility of lower total cost of ownership. We have now a software platform that is common all the way from the cloud to the edge. It opens possibilities for more services or the revenue models. So with all that, again, there is a need for that transformation to bring what we call the virtualization of the network by deploying what I mentioned before, service architectures or cloud network architectures and designs. Intel, as Alex mentioned, we have a very rich portfolio of products and IP and network products. We are here to work with our customers to provide all the solutions that they need to make them successful. And again, this is an industry effort. This is an ecosystem effort. So we're working with the industry, with the ecosystem, to bring the best as soon as possible of 5G.
Alex, Cristina's just given us a great overview of the radio access network, but what about the core network? What progress are we making in the core, and what's next for its transformation?
Wow, the core network is on its journey as well. I talked about NFV. NFV really took place towards the tail end of the freezing of the LTE network. And so, there are elements of the LTE network that actually got virtualized. Now, as we move into 5G, the early deployments of 5G used the new radio base stations, but connected to the 4G virtual EPC network. So think of that as new radio base stations of 5G connecting to an existing core network. We're at the very beginning of the transformation of the 4G core network to a new next generation 5G core network, what we call a 5G standalone core. And if you look at this graphic, what we have depicted is essentially that we're seeing the first wave of the transformation and the upgrade to this new 5G standalone core network in 2020. with early service providers implementing this network, and then followed in 2021 and 2022 by other operators. And so we see the majority of operators starting to deploy this 5G standalone core network between 2020 and 2022, and then another tail, a longer tail of other service providers coming on to deploy additional 5G standalone networks with incremental enhancements over time with the release of new 3GPP specifications, release 17 and onwards, throughout the next decade. Overall, though, the core network, we see roughly, according to IHS Omdia, in a survey that they completed at the beginning of this year, they reported seeing roughly 67% of operators having deployed 5G standalone networks by 2021. And this is a pretty sizable market. The overall wireless core market is roughly at 7.68 billion today and projected to grow to 10 billion, 9.7 billion to be exact, by 2024. The really other interesting aspect of the 5G core network is that it is built on a services-based architecture, which allows for a tremendous amount of flexibility and agility to set up and tear down and manage new services, along with the fact that the 5G network is actually seeing a build out of the 5G edge. Now, I know the edge is a big word because there are many, many edges, probably an infinite number of edges along the network. But if you look at the core network itself, there are certain functions in the core that are distributing to the near edge, or what we call the central office. This is a regional edge, like a metro POP central office that sits closer to the end user, where some of these core functions, namely the user pane function, is going to reside. And Intel provides, compute solutions, not just for the core network at its central sites, but also the beauty of what we can provide along with the ecosystem is to land a lot of these functions on a common platform, a common architecture that scales from the core now to the new build out of the edge and ultimately into the radio access network over time. But we are able to deliver common platforms from the core to the next generation central office to the near edge to host all of the core functions that are needed to realize the promise of 5G, connected to the new radio access network.
Cristina, listening to both you and Alex, it sounds like there's a lot more work still to be done. What are we going to see next on the path to 5G?
I agree, Guy. There is always more work to do. I have to say, however, it is a very exciting time on the network space. Look, just this year, we are expecting to see more than 800,000 base stations shipped around the world, just alone this year. Most of the analysts are predicting that in the next 3 to 5 years, we'll see massive deployment of 5G and the full use, full promise of 5G and the new use cases. So again, very exciting. We are going to see, and we're seeing trends coming up, and we'll continue to see them. For example, the creation and deployment of a new service by application developers, the creation and use of intelligence in all part of the network, the use of private networks and private network slices, the massive deployment again of cloud native and service-based architecture, like Alex was mentioning. So again, very, very exciting. We are very happy to be working with the rest of the industry. This is, again, an industry effort. We are looking forward to continue working with our partners, the new partners, bringing new innovations into the network. And just bottom line, at the end of the day, accelerating the full promise of 5G.
Very good to hear. Cristina and Alex, thank you both very much indeed for joining us on the programme. And you can watch additional interviews and discussions on 5G as part of the Intel Network and Edge V Summit series. There is still a lot more great content to come. But for now, thank you for watching and goodbye.